Okay, so we're finishing up this last little bit of the study guide here, and we're on number 22 where it says define inertia. Okay, so inertia we said is an object's resistance to change. So basically, if it's going in a direction, it's going to stay in that direction at the same velocity, which means the same speed and same direction, unless acted upon by an unbalanced force. But we know for real that unbalanced forces happen all the time. Things like friction, gravity, this sort of thing. All right, so tendency of a moving object to continue in a straight line or in a straight line like with that same exact speed, or a stationary object. Stationary means not moving. To remain in place. Okay. All right, so we are on number 23 now. It says describe Newton's second law of motion. So Newton's second law of motion, we go down here to our PowerPoint, and Newton's second law of motion is basically just a formula. Okay, force equals mass times acceleration. The net force of an object is equal to the product of its mass and its acceleration. Bottom line is force equals mass times acceleration. When I ask you about Newton's second law of motion, that's what I want to pop into your brain. Force equals mass times acceleration. Okay, and Newton's second example, an example of Newton's second law of motion, is going to look a lot like a math problem. Okay, so here's an example of an example of Newton's second law of motion. Basically what it is you're given a mass, in this case 1,400 kilograms, and you're given an acceleration, in this case 2 meters per second, and you just multiply the two. And in this case it's 1,400, yeah, 1,400 times 2, right, which is 2,800. I'm going to give you a little bit of a different example just to kind of mix it up. So this says a falling object accelerates as it falls. If the mass equals 20 kilograms and acceleration equals 2 meters per second squared, then F equals m times a, where mass is 20 and acceleration is 2, so force equals 40 newtons. And it's very important that we understand that like we said on the front of the paper, the SI unit for for force is the Newton. Okay. All right, number 25 says describe Newton's third law of motion. This is probably the one that you are most familiar with. You hear this on television and whatnot. There's a bottom line right there. For every action, there's an equal and opposite reaction. Okay. For every action, there is an equal and opposite reaction. Okay, what's an example of Newton's third law of motion? We see a number of examples here. So, for example, you sitting in the chair right now, your body is exerting a downward force, the chair is exerting an upward force. This one right here, this bird, it's a little bit challenging to see. There we go. Bird flying gracefully through the air. The bird is pushing down on the wings and the air is pushing up. Okay, that's what gives them lift. Those are a couple of examples. Another example is A chair with wheels. Moves back. When the teacher pushes on the desk. You all recall this when I was going over these notes. I push one way and I go the opposite way. Okay, just kind of like visualize, picture that. All right, difference between speed and velocity. Pretty sure I already went over this. Pretty sure you already know the answer. But JIC, the difference between speed and velocity? Velocity takes into account what? Direction. Speed does not. Alrighty, and that is that, my friends. I would strongly encourage you to study this. Know this like the back of your hand, okay, so that you can be successful on the test, which is going to be tomorrow, okay? So study this, do your best, make me proud. I'm going to be checking your IA scores on Wednesday or whenever it is. I can't keep the date straight, but whenever you take that test, I'm going to be checking from San Diego to make sure that you are on point, that you're not messing around. I got eyes everywhere, okay? Make sure you're on point. And good luck, my people. I miss you guys. I will see you soon. Have a great day.